Okay, so we're continuing on the arrays. So the arrays are not just limited to containing primitive data. You can contain objects, and the more common object that is available, that is used a lot, is strings. So here is an array named called names, and it's of type strings. And you can see that you can then put string values or string objects inside of this array. So when it's initially created or initialized, unlike setting all the primitives to zero, Java will set all the elements of an object to be null, and then you need to then instantiate the object and put them inside. So here, you're just instantiating an array of string references, not the actual string object. And then after you've instantiated, then you can go about and actually creating an object and putting them into each of those string element. It's the actual string elements. So there's, of course, all the string methods available, and then you can still call them while using them as elements inside the array. So for example, here, names is the array of strings. You're getting to one specific element inside the string array, and then calling string methods. And then keep in mind that there are a length field and then a length method. So the length field is actually on the array, and or versus the length method is on the string object. So you can see here that when we used it on the array, we didn't need parentheses because it's not really a method, it's actually a field or attribute, versus the length here on the string is actually a method, and that's the reason why we use parentheses here. So since strings are objects, that means that we can actually create other kinds of objects or use other types of objects and create an array of other types of objects. So here there's an object called bank account, and then we're creating an array of bank accounts. And then similarly for the strings, we need to instantiate the actual object and put them into each element of the array. So now that we have all these types of arrays, one of the common things that we need to do is be able to search for an element inside our array. And so there's the concept that we need to do a search or search algorithm, execute a search algorithm in the array. And in this case, the one that we're talking about here is the sequential search. So just starting at the beginning and then going through each one in the array. And then as soon as you find it, you return with that object, or you get to the end of the array if you can't find it. There is also the concepts of a two-dimensional array. So an array of arrays, okay? So you can think of it as like a grid or having rows and columns. So if you then declare a data type with two sets of square brackets, the variable name, and then you instantiate the size here like this, then you are defining a two-dimensional array of n number of rows and n number of columns. And so when you access each element, you have to use two indices, one for the row and the other one for the column. So just like here, this just visually demonstrates that when you're trying to access the two-dimensional array called scores to get to row 0 and column 0, you use this notation, versus getting to row 1, column 3, you use this notation. And so this is just an example of that similar concept that you use two different indices to get to a specific value, either to do an assignment or to get the value. So here, this is in a way of iterating through each element in a two-dimensional array. So you can create an outer loop here, and you're going from row 0 to the end of the row, and then you're going from each column. And then you can enter in a value into here. That's the example here. And here, this is similar. It's just actually printing out versus setting the values in a two-dimensional array. So when you initialize it, you can do a couple of ways to initialize it. One is using some static values like these. These are just initial small set of initializations, and you're basically initializing it. Each set here, you could think of it as a row. So row 0, row 1, row 2. Okay, so it's going to look like this when it's actually in memory. And this is going to represent column 0, column 1, column 2. And then this is another representation of that similar two-dimensional integer array. So since we have a two-dimensional array, the length field has different meaning depending on whether you are looking at the number of rows or then you're looking at the number of columns in each row. One key important thing here is that each row can have a different number of columns. Okay, so if you look at this example here, the first row has 4 elements. The second row here has 3 elements. And then the third row here has 4 elements. So they're not necessarily going to be consistent. This is just just a sample algorithm of calculating the sum in a two-dimensional array. Okay. And one thing that keep in mind, because we could have a variable number of columns like this, that you do need to be able to, for each row, determine the number of column elements in that one row. You cannot assume that they all have the same number of, that is a uniform two-dimensional array. And this is just a way to do a sum of getting a sum of each row versus the sum of the entire two-dimensional grid. And then this is a way of doing a sum of at the column level versus at the row level. Okay. But doing it this way, you do need to be careful that you do need to use these length attributes on each one, because if the number of elements in each row is not the same, that if the first one was 4, the second one was 3, that this is not going to work quite right. And then you can pass two-dimensional arrays into a function or method, and that's going to work just like any other kind of passing, just like passing like a single-dimensional array as a parameter into a function. So this is a way this is basically a way that in a two-dimensional array, that the number of elements inside of the two-dimensional array might be have different number of elements or different number of columns. So here, first you create 4 rows with no specific columns, and then here, after you go through each row and then set up a dynamic number of elements in each row. There is a way to actually do more than 2 dimensions, but it's not probably easy to visualize. But there can be a lot of problems that can be solved using 3 or 4 dimensional or more dimensional arrays. Now, this is a way basically of being able to, given an array, sorting the elements inside the array. So the first element in the array would be the smallest value, and then the next one would be at the next element and so forth. And basically, it will, if you do this kind of, have this kind of concept in your array, you would know that the smallest element is in the front of the array, and then the largest element is at the end of the array. The concept of a binary search is that once you do have your array in this sorted manner, like here, that you'll be able to find the element if it's not the first one or it's not the last one in the array, then if it's somewhere in between, then you have a very quick way of finding that specific element in the array, assuming that everything is sorted, and then you basically search things through a binary search. And this can be done through recursion, which we haven't yet talked about, but you can do this repetitively until you find the right one inside the array. Or if you don't find it, then you exhaustively search and you then return that you couldn't find it. Now there's a concept of, since we're still talking about arrays and strings, the most common array of strings that we see is actually the main function. So the main function, the argument in the main function is actually an array of strings. And how this is used is that when Java is invoked or started from the command line, you can actually pass some specific parameters from the operating system into the Java program. And you can then have certain customized behavior of the program based on the invocation from the operating system or from the command line. So here, when you do something like this, you write a program called command line, and you say, these are the 4 parameters that I'm passing into the as command line arguments. Then each, actually, this is 0, 1, 2, and 3. This is a little bit of a typo here. And then since there can be variable lengths of values passed into a function, you can do another way, which is called var_arg, and that's another way of passing in a variable number of parameters into a function. Next is another kind of special kind of way to do arrays, and there's a special class inside of Java called ArrayList. An ArrayList is different than the built-in Java array. This is another way of dealing with array or list. The special thing about ArrayList is that unlike the regular array is that we can expand and shrink depending on the number of elements that are inside of the array list. And you have to do this special import to get access to this Java object called ArrayList. And when you create the array list, you specify the type of object you want to put in the array list. You put these less than and greater than symbols, and you put the data type inside. Okay. And if you try to store anything else in here, you'll get this error when you try to put something other than what you defined it with into the array list. So there is methods that you can use that are in the documentation for ArrayList. And the most common one is adding elements into the array list. And then next one is getting the size or the number of elements inside the array list. And then to get to the specific element inside the array list, you can use the get call. Just like the using the square brackets and the index values for the regular array, ArrayList uses the get API and then the get method and uses parentheses to get to the index of that element in the array list. So here, since there is a way to basically this array list has a toString method. That means that when you actually do a system out print line of the array list, and in the standard output, it would actually print out every element inside to the standard out or to the print writer, assuming that the object inside supports the toString. And then you can do a remove to remove the element from the array list. So you can add elements to the end of the array list, or you can insert it at certain positions. So let's say that you want to just add it. When you just add it to the end, you do this add. But when you're trying to insert it to a specific position inside the array list, you provide it the index. Okay. And then you can actually replace an element in the array list so that you can then, instead of inserting it, it can just replace an element in that array list. So it has a capacity. So the default capacity is what is supported by the library when you first instantiate the array list. And the default capacity is 10. And then after it reaches some number, then it will automatically allocate more space inside of it and to allow you to expand it beyond the initial capacity. But you can actually specify a different initial capacity when you instantiate the array list and doing it like this. So basically, we can create not just an array list of strings, but we can create an array list of any kind of object. So here is a way of using an array list with a custom object called bank account. And there's a kind of a special thing with the later versions of Java that when you instantiate it, you don't need to specify the data type again here from string. You don't need to repeat it again here. Java, during its compile time, will know that this data type is going to match this one. And so you can just skip the data type here. And then the same thing here, you can, we've seen var, so this one will know that it's going to know what the data type of this name list based on what's on the right side.